Hello, everybody. I'm just going to sit here and natter for a few minutes to watch while the number goes up as people kind of drop into the video. So this session is really building on last week's session, but there's no need to have watched last week's session if you haven't. So I've built a small library. It's really a couple of hours of code so far, so it's really not very big, but I think today is probably a good time to do some of the sort of bookkeeping that you need to do around a project that you want to publish. So we're going to look at packaging the project properly, publishing it to PyPI, lots of words beginning with P. So it's going to be quite a Python heavy session this week, not necessarily Python in terms of like code, but certainly Python in terms of the ecosystem and the technology. And then I am going to look at getting reasonable test coverage. It's not going to be an amazing set of tests, but as I say, it's early days at the moment with this project. So I am going to write some or show you some pytest tests that I wrote last week, show you how to run them, which is kind of intertwined with packaging the project. And then I think probably the most interesting bit of this session, I'm going to build some fixtures that I'm going to use next week. So next week, I'm going to start talking about how my data abstraction library can update data, save data in MongoDB. And in order to test that, we're really going to want to test against a real MongoDB database. So the idea is that you'll be able to run tests that change data in the database. You can check that data has changed inside the database. And then at the end of your test, the changes you made will all be rolled back. So we're taking advantage of MongoDB's transaction capabilities, but we're just automating it by making it pytest fixture. We're making it sort of a background thing, much in the same way as Django has automated tests that will run in a database transaction and then roll back, but that will be with a relational database. We're going to implement essentially the same feature with pytest and MongoDB. Patrick thinks that's interesting. It seems like he groaned before it. It's difficult to know how to interpret that R sound, but I'm glad you're looking forward to that, Patrick. Patrick is a friend of mine from various Python conferences over the years, so it's nice to see you online, sort of in between conferences. It's good. So, I think you're also the primary author of Strawberry, aren't you? The oh, my mind's gone blank. Facebook query technology. Yes, the Strawberry library for Django allows you to do queries. I'm sure you can write that in the comments, Patrick, exactly what the technology that is just not coming to mind right now. This is what happens when you're broadcasting live. Your brain just turns to mush. GraphQL, thank you very much. There we go. Incidentally, GraphQL, another feature that we have built into MongoDB Atlas. So you can just kind of press a button and enable a default sort of GraphQL interface to your database. You can then configure to make work the way that you want to. So there you go. I get to push MongoDB on you anyway. Right. Well, we have a small number of people. The main reason I record these is for posterity, so people can come and find them later. And it seems like quite a few people did in the last week. So that seems to be working. If you have any questions while I'm going through stuff, like just feel free to stop me. I'm happy to talk about the stuff that I'm working on, anything related to that. If you want to talk about MongoDB stuff, feel free to drop in a question. And if I have time, I'm happy to pretty much cover anything. So I am going to share my screen, which I could have done before we went live, but I didn't. So share screen, and we're going to pick a window. So I'm just going to cover some API. That's the one. So there we go. This is actually the pytest reference documentation, which I've been using to work out how to build and test a fixture. I'm going to be working, I just want to show you some sample data at the moment. So this is something I was working with last week, but I don't know that I necessarily demonstrated. So I have this very small database. It has 2 documents in it. I'm just kind of using this data for testing. I haven't actually really talked to MongoDB yet. I've been working with documents as Python dictionaries, which is sort of how they're returned to you anyway. But here's some data. I'm going to be copying and pasting this into my tests later. So I just thought it would be good for you to see where they came from. And also, once we get to the rolling back transactions, I'm going to come back to the screen and show you that either data is being stored or being rolled back. So we're not actually modifying the database. So that's my database. This is the project that I'm actually going to be working on today. So this is where I kind of left it more or less last week. I have made some changes today. So I guess I'll go through this in the editor rather than in the browser, but just to kind of talk about the mission statement, I'm building a data access library. I'm tempted to call it an object document mapper, which is the sort of terminology the MongoDB community tends to use, because it is a mapping layer between the objects in your application and the documents in your database. But I feel like most of the ODMs out there at the moment really attempt to do a kind of deserialization, the sort of a direct one-to-one mapping. So the object that's stored in your database kind of represents, or the document that's stored in your database kind of represents an object in your application. And as your database gets bigger and more complex and you need to optimize things, that's not necessarily the way that you're going to store your data. You're going to want to change your schema, design your schema around the queries that you're doing, so that your indexes are efficient for the queries that you're doing, but don't get too large, so that data that you want to look up together is generally stored together, but potentially if there's extra data there. So I've been using an example of a blog with lots of comments. You might store the first 10 comments in the blog document, because those are always going to be seen on the screen. But if the user is going to click next or scroll down the page to load more comments, you might store those in other documents that are then requested on demand, because you're not always going to get people scrolling down beyond the sort of the bottom of the screen and looking at those. So there's no point in requesting that data or calculating values potentially, unless it's actually going to be useful to people. So I think I have a banner. No, of course I don't have a banner. It's in the description for the YouTube video. We have a whole load of documentation on the MongoDB website about modeling some design patterns that we tend to recommend. If you haven't come across those before, those are kind of really just beyond learning the basics in MongoDB. They'll solve a whole load of your problems as your data gets bigger and more complex, or your application gets more users, which is a great problem to have, right? So there's also an hour after this session. So I'm going to finish in about 50 minutes time, and then it's going to be an hour. And then my colleagues Jesse and Michael are going to be doing a specific data modeling stream. So if that's the sort of aspect of this stream that you're more interested in, I really recommend going along to that. I think it's an office hours kind of session, so any questions you have around your own data models, they will be able to answer for you. So with that said, let me run you through what I wrote last week. So it's some relatively complicated, not complicated Python, but it's some relatively advanced Python. So we've used some features like the descriptor pattern to allow us to build these sort of structures that do a little bit of magic under the hood. So let me show you what I mean. So I'm going to share my screen, and then I'm going to find window, and then hopefully, what have I got on the screen here? pyproject.toml. Okay, let me make this text a little bit bigger. If you have any problems reading the text that I've got on the screen, just let me know, and I'll make it a bit bigger. But it's like trying to find that balance between readable and useful, like getting enough information on the screen is very tricky. So at the moment, everything is in one file. We've got about 75 lines of code, including blank lines. And really, so this is, if you've worked with Django before, this is really attempting to model documents or objects, actually. Let's call them objects. Let's separate them from documents in the database, and field types that you might have, which are actually not so much the type of data that you have in the database, but the mapping, the kind of the transformation you want to do to that data to get it into your Python code. So I think it's probably best to look at the tests that I've written that sort of demonstrate this. This is maybe, these are very much tests for the code that I've got. So let me write another test that's maybe a little bit easier to understand. Tails. All right, so I've got this cocktail data. And really, so what the problem we're really trying to solve initially with the first couple of field types is that we might have an object that does mostly map to a document in your database. But your database, imagine it contains billions of documents or terabytes of data. If your schema changes, you can't necessarily afford to do a big bang change to every document in your database. So what you're going to need to do is migrate that data over time. And this is the great thing about MongoDB, that you're not restricted to a table where every row has to have the same data in it or the same structure. The different documents in a collection can have slightly different structures, or they can have very different structures, but we generally don't recommend that. And so you can migrate that data in whatever time frame makes sense to you. So you can run a background script that just does it in, let's say, a few hours or a few days. We have some customers at MongoDB who, if they were essentially hammering the database to do updates, it would take, I think, 2 years from start to finish to update every document in the database to their latest schema. So for many of our sort of larger customers, that's really not an option. So what they need to do is actually, as they're migrating over time, they need their application to keep on running. And that means that they need to be able to manage more than one schema version in their database at the same time. This is the document versioning pattern in that pattern document that I've linked in the description. So the way I'm looking at this with the cocktail data that I showed you before, and let me just kind of copy and paste that one of these into here. Oops. Not clone. I've clicked the wrong button. Not that you can see. You can't see me make mistakes. It's all good. So I've got this BSON document. So it's a Manhattan. I'm just going to paste this in. I think this is actually JSON. So we've got a value like true there. Let me just, I think because the syntax isn't right, it's not reformatting it because I do have black installed on here. So we've got an ID, we've got a name, got a description. I wasn't using, I couldn't come up with a very good example last time for something that might change. Let's say favorite is true. Let's say that was gradually being changed to, no, that's a bad example as well. Let's just say each of these has some comments in it. And so at the very start, we would just have comments, and then this might be an array of sort of strings. Actually, that was an object, but let's call it strings. So it's like, I love this cocktail. Meh. It's not for me. Now, there's a calculation you might want to do, and you can do this in the query language. I can ask it how long the comments array is, but potentially it's more complex data, and I might be calculating an average or some actual complex mathematical thing. And I'm not going to want to do that again and again and again. So in fact, we're just going to do, I think it's called a pre-calculation pattern. Calling it a pattern is maybe an exaggeration, but we would actually pre-calculate a value and store it back on the document, so that it's not being calculated on read. It's essentially being calculated on write. So here we would store comments length, and we'll call that 2. So this is a bit of a toy example. So I might want to calculate this on demand. So our original schema would have been something like cocktail and then name, and I've got this. It's called simple. And I actually don't need to tell it anything. It knows that it's called name. It knows that by default this maps to the name field. We might, in our later schema, rename this to say cocktail name. And now we've got documents. So we've got documents that don't have comment length, and we might have documents that don't have cocktail name. They've got name instead. I'm not sure why it was so important to change name to cocktail name. It's something you would avoid generally. There's 2 things that we can do here. So with simple, let's go back to the actual code. So now I've sort of described the purpose of all of this. Simple, I can override the field name. So by default, it's none, in which case it uses the name it was given to look it up. But I can actually, I can just override that. So once we've actually settled on the new field name, I can call that cocktail. And this will work. But for the whole time that we've got multiple names, so we've got some that have names, some that have cocktail name, this isn't going to work so well. So I created another one that's not simple. I'm going to rename these to simple field and fallback field. I can't remember, maybe fall through field. But the idea here is the fall through, you can give it a series of names and it will just look them up in order. And the first time it finds one that actually exists, it will return that value. So using the descriptor pattern here, the set name means that when this is assigned to a class, it will be told what the name of the field it's been assigned to is, and get is just called automatically when you do attribute lookup behind the scenes. So it's like a magic thing. It's how properties work in Python. It's how static field, class method, static method work in Python. Definitely recommend looking up the descriptor protocol if you haven't come across it. So this was fall through, and instead of field name, I think I called this field names. Yes, field names, and then this will be name and cocktail name. So this will now work with documents with both this schema, the updated one, and the old schema as well. So this is really the idea. Like, I'm trying to build an abstraction over the way the data is actually stored in a database. Later on, we're going to have this when it does calculations like the comments length, it's automatically going to write that back to the document for you so that it doesn't have to be recalculated by other clients. I'm also going to abstract out joins so that when we have something like the first 20 comments embedded, as you start to loop through them, when it gets to the end of that 20, it's going to do another query and start to pull in the other comments automatically. Yeah, we're going to do a bunch of quite clever stuff with this library. So it started very simple, but I just wanted to get past this stage of just like, this project isn't really a project yet. It didn't have a license until an hour ago, and the PyProject TOML didn't work last week. So let's talk about why I want to package it. So the first thing is, I think this is ultimately going to be useful to people. And so I want to get it up on PyPI so that people can start to make use of it, or at least have a look and comment on it, try it out. The way that you do that is you write this configuration file. This would have been a system.py system. That is the wrong word. My mind's gone completely blank today. I should have had a coffee. Didn't have quite enough time for a coffee before this live stream. So yeah, we would have had a configuration file that once was Python, and then there was a configuration file that replaced it. And then now we would generally put it in a PyProject TOML. And we also have the advantage that we're not sort of restricted to using dist-utils or setup tools for building and packaging our libraries. There's a whole bunch of things out there from including Flit, and hatchling is one of them. Hatchling is one that I quite like. I know some people using this in production who have recommended it, so I'm going with hatchling for no other reason than that, like just using the recommendations that people have given me. I've written this file. It's not very interesting. I've basically been going through the packaging tutorial. The important things here are the name, the version number, which I've actually just bumped up to 002 to make sure that I don't have problems when I try to publish it. I've written a short description, told it where the README file is, told it that it needs to use a recent version of Python. Some of the features that I plan to use are Python 3.7 beyond. So I'm just ensuring that it uses Python 3.7 beyond. And at the moment, its only dependency is PyMongo. In fact, I'm not even sure that's a dependency yet, but it will be. So I've restricted it to the latest version. Later, when I've got a test matrix set up, I can test against different versions of PyMongo and different versions of Python and any other dependencies we have. And when I know those work, I can relax this and just kind of say, yeah, it'll work with PyMongo 3 and 4 up to 4.6 or whatever. I can identify problems in older versions of PyMongo. I've said that this is still in planning stage. I mean, barely even in alpha. I mean, I wouldn't even say it's in alpha. It's in very, very early planning, sort of development stage. And I've told it where the GitHub repo is. And that's basically all you need to publish a package. So the next step is, once I've written this and I've stuck it in this PyProject TOML file at the top level, I can install the things that I need to build and deploy it. And those are Python -n pip. You may just run pip sometimes, but if your paths get messed up, it can run the wrong pip, and then you don't get things installed to the right place. So instead, if you run it through Python, it means that it's definitely the pip that's associated with the Python command tool that you're running. So it'll definitely work. So this is kind of the recommended way to run Python tools these days. So I'm pip installing and upgrading. Oh, install. Nice upgrade. And I want Twine. It's helpful, hopefully auto-completing. Twine is the thing that will allow me to publish to PyPI. And the other thing is build, I think. Haven't got the documentation on my screen at the moment. So happen to have installed all these earlier. Once they're installed, I can now run them. Python-m. I would normally write a just file so that I can do just build and just deploy, and then it would automate a lot of these longer command lines, but I won't worry about that at the moment. Pip, so I'm not pip, I'm running build. So if I just run this, it creates me a new virtual environment, it installs my dependencies to it, and then it kind of packages everything up in there, which is kind of cool. Excuse me a moment. So there we go, building a wheel, and it successfully built it. So it's built a tar file and a wheel file, both of which we kind of want to deploy, and that is done through the Twine tool that I just installed. Python -o, and again, it's run kind of the same way. And you tell it to upload. In this case, before you deploy to the main PyPI, we can deploy to test PyPI. So I was talking to one of the ops people who helps maintain PyPI at PyCon a few years ago, and I was saying that I really appreciated the fact there was a test PyPI, and he looked slightly guilty and said they'd just taken test version offline. So you had to just deploy to PyPI and hope that everything's okay. Because once you've deployed version 2, for example, you cannot then push a new version 2 to PyPI. So it's kind of a one-way operation. So having this ability is really nice. My username is Bedman Mark, for reasons that are even less interesting that my usual username is GD2K. And then it's going to ask for a password, which I keep in a password safe that you are not going to see. I successfully did this earlier today, so I know I have. There we go. Oh, bad request 400. I swear this worked just a moment ago. Let me check if my username isn't Bedman Mark. Maybe it's GD2K. Nope, and that was just the bad authentication. So I haven't got a verified primary email address. So I'm guessing this has just sent me an email. So after I deployed last time, and so let me just check off screen. I apologize for this. Never demonstrate technology. That's rule number 1. It's my rule number 1 anyway. It would be nice to get this working. If not, I'm going to have to do it after the call. I cannot see an email that has come in. So I'm just going to pretend that this worked. Oh, that one had my password was empty. That's interesting. Let me. That will have been my password safe, erasing my pasteboard. So let me try this again with GD2K. I may have made a mistake. No. Okay, I have a different account with the main PyPI repository, and I did test this earlier. So let me just have a go at doing a production deploy. This is just going to be one of those days, isn't it? They're not catching the keyboard interrupts. Maybe that's something that somebody could contribute to Twine if they're looking for an open source contribution. It's like, okay, this is not going to work for me today. Sometimes these things just don't. The important thing is that I can build my project. So I'm just looking for you all again. There we go. Make sure everything's okay. Right. So now I built my project. I ran the build command. You saw that worked. So let me just clear my screen. And now I can run pytest. So I've already installed pytest. That was just a pip install pytest. And then I've told it my tests are in a tests directory, which is kind of the default. And so it should just run them. But it's not going to, because it can't find the module called docbridge. And this is the reason that I packaged the module. So if you haven't worked on a package with setup py, that was the word I was looking for earlier, before, if you haven't worked on a properly packaged project before, you may not have encountered this command. So python -m pip install -e full stop. So what this does is, because this current directory contains a pyproject.toml, it's a Python project, it's a Python library. So that's what this full stop means. It means the current directory. So I want to install the library that's in the current directory into my current virtual environment. And this -e flag is actually short for editable. And that means that it's not going to copy my Python code into my virtual environment. So that's normally what happens when you install a Python module. Whoops, I don't know where all this is coming from. You can see I've been working on some AI stuff. So normally it copies your code into the virtual environment, and that means you can't really edit it anymore. Whereas what we want to be doing is editing the code in the source directory that I created last week, and having it still available to pytest to run tests against the live code. So that's what editable means. It says it doesn't copy it. It actually just sticks the path to your code inside your virtual environment. I'll show you where it does that in a second. So I'm just going to run this. And it gets all your dependencies. It will install all your dependencies. And then it just creates this, what's called a path file. So my virtual environment is inside my VNV folder. And then in there is the site packages folder. This is where it installs everything. So there are the things that I've installed as part of this project. You can see pytest on the right-hand side. I'm surprised PyMongo isn't in there, but yeah, we'll maybe find that in a bit. But the important thing is this docbridge.pth file, it's path file, and that. Oops, excuse me a moment. Just if I print that out, the contents of that is my source directory. This is the path to my current working directory, and the source folder where I'm keeping my code. So Python just uses that as a layer of indirection. If everything was on Unix, you could use symlinks to link to that directory. But because this also needs to work on Windows and potentially other systems that don't support symlinks, we have this kind of path technology in Python. And if I uninstall docbridge, which I can do using pip, it will just remove this path file from the library folder. So now I have docbridge installed. That means I can run Python. I can import docbridge, and this is from the top level directory. So I put my code underneath a source directory, so that I don't make any mistakes here, because normally your current directory is in your path. So I could just import docbridge without having installed it. But actually you want to install it, partly to make sure it installs, but partly to make sure that your tests are running in a kind of production environment, the same way that your code would be installed in a real piece of software. So now I can run pytest, and it will find the docbridge code, run my 2 tests, and they pass. And that's mainly because the test I just wrote, which wasn't really a test, it really just defined a class. I didn't have any tests in there. So the document is designed to take a dictionary when you instantiate it. So see a Manhattan. Let's call that Manhattan data. Equals a new cocktail, and we just pass it that. I don't know why auto-completion isn't working, but VS Code has been being a bit fiddly today. Cert Manhattan.name equals, and then it will be Manhattan, hopefully. Kind of writing that blind. Let's see if it works. Yes, it passes. So notice that although it's called name here, it's actually falling back to the second name, cocktail.name, cocktail underscore name. So it's like my sort of mapping is working. So now I have some proper tests that are working. The problem with this is it's still kind of abstract. So I haven't actually connected to MongoDB. I'm really just working with this cocktail data that I've copied and pasted into my application. And ultimately what we're going to be doing is reading and writing from the database. So really our tests need to run against MongoDB. And that can be a little bit tricky, because if I'm creating documents and saving them to the database, I'm going to be messing up my database. And there are some pytest MongoDB libraries. There are two that I know of. There's one called pytest MongoDB. That's mainly for loading fixture data in. Like, it's mainly if you have your data in files. So I might have this Manhattan recipe in a file. It's a good cocktail, by the way. If you've never had one and you like kind of whiskey cocktails, Manhattan is a really good cocktail. But if I'm saving that to the database, things are just going to get messy in between tests. Sorry, pytest MongoDB is just for loading this data in so that you can run tests against it, so that I could then query data, wrap it with a cocktail wrapper, and then check that this assertion works. So with data from the database, that's quite nice, but it's not actually what I want. I'm not that interested in loading data into the database, at least at the moment. And the other one, pytest Mongo, will connect to MongoDB. It'll load some fixtures in, and it also has the ability to clean up after itself. And I was really excited about that. I was really expecting to demonstrate how to use that in this live stream, but because of the way it does it, I don't really want to do that. So it doesn't use transactions and roll them back, which is sort of the cleanest way to do it, in my opinion. Instead, it just deletes all of the collections in your database in between tests. And that just seems like using a hammer to crack a nut, especially if you are loading fixture data in. It's like, I don't want to delete all the collections, then load the fixture data in, and then run the test again. I want to rely on MongoDB's transactions to clean up the data for me. So let's write a fixture to do this for us. Fixtures in pytest are kind of magic. If you've never used them before, that's just kind of a warning that I should give you. So I could write the fixtures in this file, but there's some really easy mistakes you can make when writing fixtures in your test file, in the way that they're loaded and passed to your code. So I'm going to stick them in a sort of test configuration file instead, which is the advice that you get from the pytest people. So I'm just going to do my weird thing of doing this on the command line. It's called conftest by default, and it is just a Python script that's executed before your test code. So here I'm going to import pytest, and then I'm going to create. So there are two things that I need, and the first thing that I want to provide to my tests is a connection to MongoDB. So let's just create a fixture, and then a fixture is just a function that returns the thing. The simplest version is just it instantiates and returns a thing to your test code. I'll explain it in a minute. I'm going to call this MongoDB, and it doesn't rely on any other fixtures, so it doesn't need to take any parameters. Now, what this is going to do is it's just going to instantiate a MongoDB client. Oh, and there we go. I need import pymongo and import OS. So because I'm just using one variable from each of these, I'm just going to use the top level library, be a bit more verbose. So client equals pymongo.mongo client. And this, I just want to configure using an environment variable at the moment. Like later on, I can configure pytest so that it takes command line parameters, but I'm just going to assume that before running the tests, somebody has set an environment variable called mdb_URI. So I can get this from os.environ. It's just a dictionary. And then I'm just going to look up mdb URI. Then I'm going to, this is quite important in your applications. Like this is a lazy client. It doesn't do anything when you configure it like this. It doesn't try to connect to your primary or anything like that. So it's quite a good idea. I think it might be just command actually. And I think this is ping. I think I have this up in a browser screen. So just let me check before that works. Before I Admin command ping. Wow, I think I got that right first time. It's very unusual when I use one of these lesser used commands. But you should generally do that. It's going to force it to connect to the primary, and then you're going to get an error on startup to say that you can't connect to your application, which you can respond to in different ways, right? In a big sort of multi-service environment, what you might do is wait for a while and repeatedly try to connect, and then only kind of go live once you have a real connection. But in this case, I just want my tests to fail. Once I know that ping command works, I can then just return the client. The way that I use this, actually, I'm just going to copy and paste this because I'm going to use it twice. So let's just test that MongoDB fixture works. Def test MongoDB client. And you look these up by name. So these are passed to you by name. So I've created a fixture called MongoDB. And that means if I create a parameter for one of my tests called MongoDB, it will call the function and just pass me what's returned from this. So I can now assert, I don't know actually what this returns. I think it returns true. So the thing that's returned is a client, but because I've called the fixture MongoDB, I'm just going to refer to it as MongoDB. I think this is true. Maybe. Let's check. This is a great thing about test-driven development. You can test things without fear. So actually, it doesn't return true. It returns a data structure that contains the cluster time and some other stuff. Maybe it's in here. It's kind of been shortened. I could do, there's an OK in there. So let's just check that that's, and it's 1.0. I wish it wasn't, but OK comes back as 1.0. So we can look that up by key, K, 1.0. Here we go. Let's try that. Yay, test works. Okay. If your cluster is wrong or your MDB URI is not quite right, you'll get back different errors based on that, which is kind of handy before your tests start. There is one thing I need to do before finishing that off, which is to tell it how long this fixture lives for. So at the moment, this will be created. This connection. This will be executed for every test. That's the default. But actually, I can't remember what this is called now. I did it earlier. Let me just look it up. Pytest. I'm Googling for pytest fixture scope. That's the word that I'm looking for. And I want the scope to be session. So what that means is that this connection will be made at the start of my test run, and then it will be shut down. In this case, it won't be shut down because it's not. That's not something that it's doing here, but it will last for the entire test run, and it will be reused. Like the client that's returned will be reused with every test. So that's kind of what I want. A MongoDB Mongo client is a reusable object. Now let's write a test that actually modifies the database. Update MongoDB, and I'm just going to take the MongoDB client, and then I'm going to create a test database and create a test collection. MongoDB bridge. So that's my database, and then my collection is pytest tests. Dot insert one. And then I'm just going to give it an ID. So just to make sure this can't run twice in a row, I'm going to give it a fixed ID so that we get a conflict because they're not unique. And I'm going to give it bad document. And then description. If this still exists, then transactions aren't working. Right. So let me run my test again. Okay, so they passed because I'm not actually validating anything in this test. But the problem is once this test is finished, it's not cleaning up the database. So let me just switch my screen share so that we can have a look in that database again. I wish that there was a slightly faster way to switch between applications, but Never mind. Window, and need to find the right one. Data cloud, share. So this is my cocktail database. I'm going to have to refresh this to get my new databases and collections. And what it was called dot bridge. And then we should have tests. Oh, wrong one. Tests. And then there we go. My bad document is there. So I don't want that to be there. So I am going to delete that. Obviously, that's unfeasible for every time I run my test run. So let's create a fixture that rolls back all the changes in between tests. So I'm just going to go back to VS Code. Test.bridge. There we go. Share. Right. So what I need is a session. I'm going to call it a rollback session. That's what I'm going to call this fixture. So, and there's one last thing, which is that when you have an ongoing session, you need to pass that to each of your commands that you're executing against MongoDB. So actually, this needs an extra parameter there, and we're just going to pass it the session that we're using. So now I need a new fixture. Oh, I've just realized I put that in the wrong place. Ha! Hope there are no pytest experts on this stream, because that was kind of silly. That's this week's silly mistake. Last week I kept forgetting to instantiate variables. I just kept sort of referring to them in init functions. So this will be called, oops, I've done a copy and paste since. This was called rollback session. And it's going to require a MongoDB client. And this is, again, fixtures can be passed to fixtures. So this will automatically be passed in. And then the way that I do this is I create a session. So I do that with session equals mongodb.start session. And then I can start a transaction. So session.start transaction. And then I'm going to want to run my test. So at this point, I can yield the session. So that's the session. That's the variable that will be then passed into my test functions. And then afterwards, I want to clean up the transaction. So this is dot rollback. I really wish I had completion at the moment, but we'll figure it out. Oh, it's not rollback, it's abort transaction. And obviously, if any errors occur here, that's never going to be called, which sort of leaves our session ongoing, which is not a great thing to do. So let's just add some error handling in here. And then we can do a finally, and then do the abort transaction in there. So hopefully this should work. Like this is basically it. So I've got the rollback session that's already being passed through. I'm referring to it in my call to insert one. So now, if I run pytest, yeah. So let me just, I can actually mongosh into my database. I can use .bridge. Auto completion's working here. That's nice. And then I can do db.test.find and just get back all the documents that are in there. And that's empty. So we know that rollback is actually working. So now, anytime I need to do, sorry, wrong file. Anytime I need to do a test, like inserting a document that I then want to be cleaned up, I can do. And this should get the document back. So I can assert that if I do a find one with this ID, I hope I'm sharing the right screen at the moment. I've got this horrible idea that I'm not actually sharing my VS Code. No, I am. That's good. Right. So I can do, there we go. I can look up the document that I just inserted. Sorry, insert, that should be find. And I just check that does not equal none. That's an exclamation mark and an equals, by the way. I've got a magic font that makes that look like a single not equals character, which I quite like, but it's maybe a bit confusing to anybody just dropping into the stream. Let me just exit Mongosh, and then we run pytest again. Whoa, it's none. So actually that kind of implies that my transaction is configured wrongly, which is probably a silly mistake that I've made. I was reading the documentation earlier, and it seemed all to be okay, but I hadn't actually run this test. So let's have a look at transactions. I am going to have a look. Mongo transactions. So it's worth noting that I don't use transactions very often. They are kind of something that we use a little bit academically, and they are necessary in large systems. But if you're using too many transactions, it often means that you've got related data kind of too distributed through your database, or that you're kind of relying on a level of consistency that maybe just isn't scalable in a large application. So that's just some thoughts. So primary, read concern, local, I think. I can't remember how to provide this to PyMongo. The last time I did this was in Java. So I tell you what, this is going to be a fiddly thing to fix, and I don't know that I can necessarily explain it on stream. Kind of 10 minutes from the end of my time. Anyway, this is definitely something I need to get fixed. So I'm going to be looking at this after the stream, but it's more like a configuration option than anything conceptual, and it's certainly not kind of a Python thing. And I will maybe add a comment in the YouTube video to explain kind of how I fixed it and point you at the code in GitHub. If anybody's got any questions about what I'm doing, anything that I've done so far today, like feel free to drop a question in the comments, in the chat, and I'm happy to answer any questions that you've got. Yeah, no, in the find one function. Sorry, Anshay, thank you for that. It's it's much easier often watching these things than it is writing them. Let's go. Yes, thank you. That was teamwork. Love that. I love it when people on the stream can help. Thank you for that. Also, good to see you again. How are you doing? So yeah, back to kind of what I mean. That was everything that I hoped to achieve today, except for the fact I didn't actually manage to authenticate with PyPI, despite that working like half an hour before the stream started. So I'm going to have to. That's another thing I'm going to have to follow up. But the theory's all good, and it really is just watching a command line task, just kind of print out some output while it uploads. So yeah, that's where we are there. Is there a way to do migrations with MongoDB like Django SQL? No, there isn't. Well, no, sorry, that's not quite true. So there is let me bring up a browser, because this is actually kind of a cool project, and I'm online friends with the author, so it's always nice to promote his stuff. So one of the newer ODMs, object document management, mapping libraries out there, is called Beanie, and it's been written by this guy called Roman, who was in Berlin, and I think he's now in South America somewhere. So he's had a big move in the last year. So yeah, there we go. Let's have a look. So it's this library here. So this looks a bit like what I'm developing. It's built on top of Pydantic, and it's similar in that it's similar in the way that you describe your data in the database, and it will kind of map between like recursive models and different types. It's genuinely really cool. But he has a migration framework in this. So in a similar way to Django, and I haven't used it, But in a similar way to Django, you can kind of tag different versions of your model, and it will automatically run the migrations for you. Funnily enough, this is something I implemented at an internal hackathon at MongoDB maybe 2 years ago, and it was really fun, and I used a lot of sort of under the hood Python magic. I developed it with the author of PyMongo, so it had some real expertise in there, which was quite nice. Yeah, the only reason we didn't really take it further was because it was relatively limited. It could do simple migrations, but then being able to get it to operate in the way that we wanted it to across theoretically any migration you might want to do just seemed like a bit of an overwhelming task. But I kind of wish I'd gone back to it and spent a bit more time on it. The problem we had is that we implemented 2 ways of running migrations. So it could automatically run migrations by sort of pulling documents out of the database, fixing them, and then updating them, or it could actually run. It could actually build your migration as an aggregation pipeline, and then you could run it within your database, which is in theory like a lot more efficient because you're not pulling data across the network and sort of serializing it and deserializing it and a whole bunch of other things. But again, that was relatively limited. I mean, the aggregation framework is a Turing complete language, so in theory you can do everything, but that doesn't mean you want to. So it was, yeah, we maybe should have just fixed on the doing everything in Python approach and allowed kind of an escape hatch to writing a function to doing, certain migrations. You need to write some code to manage that migration. But yeah, certainly Roman has had a stab at it with Beanie. If you do have a go at it, if you have a play with it and you like it, or even if you don't like it, just let me know. Like if you could leave a comment in the community forums, like I would love to be tagged on that. I'll have to go and check it out myself. So Beanie, for what it's worth, is async first. It is an async library. It's designed to work well with fast API, and it really does. So I highly recommend it if you're working with a kind of modern async system. If you want a synchronous version, he maintains a version of it called Bunnet, which I actually named. I named this library. I did not create that slightly scary picture, but a bunnet is a Scottish word for a peaked hat like this. So it was a conversation we had over Twitter before Twitter went bad. So okay, how are you going to maintain and observe database changes if needed? Okay, so the way that we recommend you do versioning with documents is that and I again may not be answering the question you're asking, but I'm doing my best. Is that every time you make a modification to your schema, no matter how small, you bump the schema version by 1 and you store that in the document. So you can immediately look at a document and know, is it version 1? Is it version 4? Is it version 2? And that means that you can then relatively easily do queries to see like how much of our data is out of date. I mean, with certain databases, you could even do queries to say how much my data is out of date but still active. It's like, is it that everything that's still version 1 is just data that hasn't been accessed in 5 years? Like potentially you could do some interesting stuff there with archiving data out to S3, so that it's kind of in cold storage, because you can still have that data accessible via the MongoDB query language. It's just that it's not indexed or anything. But yeah, there's some really interesting stuff I think you can do to keep your hot data relatively small and efficient and cheap, while archiving data out but still keeping it live. Did that answer your question? Just let me know, like a yes or a no would be good. I recognize your avatar. I'm trying to work out where I know you from. I don't recognize your name, but I'm very bad at names generally. That's Ismail that I'm talking about there. Sorry, I should bring these up on screen. I'm getting back into streaming. I did a lot of streaming early in the year, and then I haven't done anything for months except for last week. So I'm gradually getting a little bit warmer to the whole thing. Yeah, really appreciate your suggestion, Anshay. That's it's always dismaying when I can't fix something myself and there aren't any suggestions in the chat. So it was really nice to have a look at what you were saying. Yeah, okay. So this, just to kind of reinforce things, if you weren't on the call, if you went on the stream earlier, I'm just going to bring a banner. In an hour, my colleagues Jesse and Michael are running a session on data modeling, and I think that's kind of Q&A session. So if you have any specific questions about how you efficiently model data in MongoDB, they should be able to help you, which I think is kind of cool, and I think sort of related to what I'm trying to achieve with this library from a modeling point of view rather than a sort of code abstraction point of view. So I think that may be of interest. This is a weekly series of YouTube streams, so I'm going to be back at the same time next week. I haven't quite decided whether next week is going to be saving updates to the database or kind of transparently modeling bucketed data and joined data across documents and collections and things. So I'm going to do the joins because I haven't quite solved some of the update stuff in my head in terms of the architecture of this library, but also I just think it's quite exciting to have these iterators that transparently pull in extra data when required, but are a relatively cheap operation sort of when you're only using the first few documents. So yeah, I hope that sounds interesting. It'd be great to see some of you again next week. And with that, I think I'm gonna end the I'm going to end the stream. Thank you very much for coming. Hope to see you next week. Yeah, keep interested in MongoDB. There we go. I haven't got a slogan yet, so any suggestions for slogans, just stick them in the comments. Thanks very much. See you all.